Welcome. The next two videos are going to cover Chapter 5, Loops and Files. Before we jump into loops, let's talk a little bit about the increment and decrement operators. Plus plus is the increment operator. It adds 1 to a variable. So val plus plus is the same as val equals val plus 1. What you're going to see here is that we have both prefix, which is this, and postfixed. The prefix version, to understand that, what's going to happen is when it's on a line, so let's say we have a line, blah, 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 and somewhere in there we've got the plus plus val. When in the prefix like this, it's going to add the plus 1 to the variable and then execute the line. Where with the postfix, which is one of the more often ones that we see, we have our line here, and then we have the val plus plus. It will actually execute the line of code first and then increment the variable. I'm going to show you a little bit of that here in a moment. Now this is the look at the decrement operator. This is where we have the minus minus, and just like the plus plus, it's a decrement operator, so it takes 1 away from the variable. So we have val minus minus is the same as val equals val minus 1. And same thing here, we've got it both in prefix and postfix to the variable. So now let's take a look at this nifty little program that they gave us. But here's the problem, is their example of using post and prefix here doesn't really show you a good way of doing it. And the reason being is these lines are going to, each time we increment and decrement in this program, since it's on its own line anyways, we can't really see the benefit of the pre and post. Okay, so let's switch over to their online compiler here. And you're going to see that I have taken a snippet of the code we just had. Let's go back and you can kind of see. Here's that code that we had, and I just took a snippet of it. This is the increment part. And as we run this, we're going to see that the number is going to increment just like we thought it would. So first the number is 4. Now we'll increment the number. So we do the postfixed, and we say the number is 5. And we say I'm going to increment again. And now the number is 6. But this time, let's change it up a little bit so we can actually see how the postfix and the prefix work. We're going to actually make the number increment within the line of the cout. So now we're doing a postfix. We're going to do a prefix. And we're going to copy this line. And copy it here again. And the reason being is, in this first postfix, what should happen is we should actually see it say now the variable number is 4. because it's going to actually process this line as a line of code, and then the next step is to increment because it's a postfix. Then we're going to say I will increment number again, and then on this one we don't do any incrementing, but I want to show you that the incrementing after this line of code has processed actually finally happened, and now this will say 5. The next time we're going to do it as a pre-increment, which means it's going to increment the number first and then do the line of code. So our next cout will also have, so this should say 6, and this should also say 6 as well. So let's put a little bit of code out here, or a little comments out here. Should say 4. Should say 4 again, because remember, it's going to run the line of code and then increment. Now that that increment has finally happened, should say 5. This should say 6 because it's going to increment and then run the line. And then since it's already incremented, this would also say 6. So there you go. And this is what I was talking about. As you can see here, the number is 4. We do the increment, but we do a postfix within the line of output. And that's why you're seeing 4 again, because 4 runs, and then it will then increment in this line. And then you'll see that it says 5. Then the pre-increment, so it's 6, and then 6 again. So the important thing is to really take out of this is this post increment will actually increment the number after the line of code is ran, and the pre-increment will first increment the number and then actually do the line of code. All right. The prefix versus postfix, and this is exactly what we were just talking about. That plus and the minus operators can be used in complex statements and evaluations. In prefix mode, as we just talked about, the operator increments or decrements, then returns the value of the variable, as in it runs the line of code that it's in. In the postfix, the operator returns the value of the variable, then increments or decrements, or as I just showed, it runs that line of code with it in the value that it already is, and then does the incrementing or decrementing. This is another fancy way to show exactly what we just did in our program, and that is where we have an int number, the value is 12. When we do the cout, because it is on the same line, this is all on the same line, it's going to display 12 first. And now that it's done that, it's now incremented val, so now val here will equal 13. But because the next line we're doing a pre, it's going to take that 13 and it's going to make this go up first to 14 and then do this line. So that's why we see 14. Before this line gets output, the pre is going to decrement it, so it's going to make it go back to 13, and that's why we're going to see that num actually equals 13. And then the post increment is going to make num 13 again, because it's going to do this decrement on the val after it runs that line. So it's going to put 13 in first and then make it 12. On this, I would definitely tell you, play with it a little bit. Get your online compiler out and play with the prefix and postfix. Also, this is the most common. Well, Most of the time, we're going to use the post, believe it or not. You would think that you'd want to use the prefix, but no. Most of the time, you're going to be using the post. And you just don't really see this too often. It does happen, but not too often. So some notes on incrementing and decrementing. It can be used in expressions. So this is a pretty big no-no in most organizations, and the reason being is that really makes that line of code extremely difficult to read. And when you're going to debug this at some point in your life, you're going to be really mad at yourself for using that line of code. But what's going to happen is it's going to make num1, it's going to not worry about this at first because it's a post. It's going to first decrement num2, so it is going to do this, making num2 go down. And then it's going to plus that to num1 that has not incremented and assign that to result. And then after that has happened, num1 will go up one in incrementing because it's a post increment. Again, that's why you would never use that line of code. It's just too complicated. There would have to be a real reason. And I think as a program manager, I would be expecting, assuming as an application manager, I would be expecting that there be a lengthy code comment of why he would have written something so complex to do something, because that's just so difficult to read. Must be applied to something that has a location in memory. Cannot have, and so what's happening is this is not truly a variable. So this is an action on variables. You can't then increment it. This has to, you would have to take this and put it in results and then do the increment. So we could do this, interestingly enough. We could say result plus plus equals num1 plus num2. And that would actually get us the similar results of what we're looking for, because it would do the num1 and num2 first, put it in result, and then as it's going to the next line of code, it would increment result by 1. It can be used in relational expressions. So because as long as our operator is on a variable, which is in memory, we can do this. Now, remember, because this is a prefix, it's going to increment num and then compare it to limit. If it was a post, it would take num as it is without incrementing, compare it to limit, and then increment it. All right. Now we're getting to, what we've done so far is a lot of fun in coding, but I will tell you, a lot of why we write code is to make things happen over and over again. So our loops are probably one of the most powerful things that we have in coding. And so now that we're getting the loops, I think you're going to find that what you start coding gets to be a little bit more fun. So let's take a look at the while loop. The while loop is a control structure that causes a statement or statements to repeat. So the general format of a while loop is this, and this, by the way, is a one-line while statement, where if we wanted multiple statements, we would have to include the bracket. So we would have while our expression, curly bracket, our lines of code, and then curly bracket. So how does the while loop work? Well, the expression is evaluated And then based on the evaluation, if it's true, the statement or statements will execute. And when they're done, it'll go back to the top and reevaluate the expression. And it keeps doing that until the expression is false. If it's false, it does not run through the following. Sorry, I misunderstood. I was trying to read this, and I was like, that doesn't make sense, but it does. If false, then the loop is finished, and the program statements following the statement don't execute. So again, if this is false, it will skip past the statements and not do any of the statements. True, it does. False, it doesn't. Now, what's neat about the while loop is this expression will always be evaluated first before any possibility of these statements can run. So you could have a while loop that never executes, because if you said while false, you actually wrote the word false in here, then this statement would never run. So you can have while statements that never actually execute because of that first expression being evaluated first. So this is kind of that logic of it. We're going to kind of come in here, check the expression. If it's true, we're going to do the statements. If not, then we're going to fall out of the while loop. Here's a quick example of a while loop. So we have our expression here that's going to be evaluated. So we set number to 1. Is number less than or equal to 5? Well, yes. So then go ahead and do this little statement. Oh, and by the way, we're going to increment number here. And so the next time it gets up here, number is now going to be 2. And it's going to increment. Now, what's neat about this actual little program is we could actually make this a little smaller, because we could say while number plus is equal to, less than or equal to 5. And then do our C out. And the reason being, and this is exactly what would function exactly the same as that, and that's because what would happen is it would first evaluate the number as it is. So let's say it's number 1, number equals 1. It would say, is 1 less than or equal to 5? Well, it sure is. Return true. And then as it goes in, as it's starting to go in here, all of a sudden the number would increment to 2. And because we never use number in here, it doesn't matter if we increment at the bottom or up here, it's going to do the same thing. So now the next time it gets up here, it's already been incremented. It's going to be 2 now. It's going to say, is it less than or equal to 5? True. So as it goes in, it's going to increment to 3, and so forth and so on. This is exactly what we just talked about. Again, we're going to test the expression. It's going to be true the first time. It's going to go in there. It's going to do its count. It's going to do its the C out of hello, and then increment the number. And then it's going to start over until it gets to where number is not less than or equal to 5. This is a flow chart. Same thing we've been talking about. The while loop is a pre-test loop. And the reason why it's a pre-test loop is because it will always execute the expression first and then fall into the code, or fall into the while loop if it's true. That's why it's known as a pre-test loop. Watch out for Watch out for infinite loops. So the loop must contain code that makes the expression become false. Otherwise, that loop will never stop. Such a loop is called an infinite loop. because it will repeat an infinite number of times. Now, with that being said, infinite loops aren't always a bad thing. Sometimes we use infinite loops because we don't want it to ever stop doing that loop. One example is demo kiosk. We will write code that goes into an infinite loop because it will, let's say, take the user, the demo user, through several demo features. And then when it's done, it's going to go back at the top of the loop. And basically, we want someone to turn that computer off to stop that loop because we never want it to come out of that loop. And so sometimes there are reasons to have infinite loops. A lot of times you'll find that it's not what you wanted because it just kind of runs away from you. But it does allow it to happen. And this is an example of an infinite loop because we never increment the number. So number is always going to stay as 1, which means this will be infinitely true. It's the same thing as writing while true, which you can do. That's how you can generate a purposeful infinite loop. Using the while loop for input validation. This is kind of like what we've done in the past a little bit with if-else statements. What we're going to do is we're going to sit in this loop, and as people enter characters in, we're going to look to see if it's valid data. If it's not, we're going to tell the user there's a problem and then stop the loop or stop coding the loop because our code's going to then go back to the top of the loop and keep going. If the user puts in a valid piece of information, we will cause the loop to break out of the loop. How does that look? So here's the general approach in pseudocode. We're going to read an item of input, and while the input is invalid, we're going to display an error message and then ask for the input again. And then this loop will continue. When the user puts something in, it's going to come right back up here and validate it's good data. If it's not, it will display and then read and do it again. If it's not, display, read, do it again. So forth and so on until the user puts in the correct piece, and then it's going to jump out of the loop. Now, interestingly enough, one of the things about this type of loop, oftentimes, not always, but oftentimes, you are going to have to prime the loop. This is known as priming the loop, and that is you're going to have to do whatever action you need done. You're going to end up doing it first outside the loop and then doing it again in the loop because this primes the loop and this will continue to feed the loop. So that's why we're reading input, a line of input first and then going to the loop, but then also doing that read again inside the loop. So that's known as priming the loop. Here's an example of what we were just talking about. We've got code that says enter a number less than 10, and then we're taking in an integer, and is while and by the way, there's the priming the loop. We're going to then say, is that number is that number greater than or equal to 10? And the reason why we're doing greater than or equal is because we're saying less than 10. So this number should be less than 10. Less than 10. Which 10, because less is not an inclusive, 10 is not part of the values. And then once that happens, if it is greater than or equal to 10, then we're going to say, hey, you've made an error, and then we're going to tell them try again, and then we're going to take the input, which then will pass up to here and see, does that number, is it greater than or equal to 10? If it isn't, then great, we've got the right type of data. We're going to fall out of the while loop and continue on with our code. Here's the flow chart of what we just did. I'll let you take a look at that. It's exactly what we just expressed. And then this is an input validation program. It's an example of validation using a loop. Take a look at this. Again, I would even say this is not a bad idea to type this into your online C++ compiler and play with it a little bit and see how it truly works and see if you can break your while loop. Counters. Now remember when we talked about incrementing and decrementing? This is kind of where the counter is going to come in. That's why we had to talk about that real quick. But let's go ahead and jump in and talk about counters. It's a variable that is incremented or decremented each time a loop repeats. Can be used to control execution of the loop, also known as the loop control variable, and it must be initialized before entering the loop. By the way, oftentimes we would consider this as priming the loop. This is us using a counter variable to control a loop. So first to understand is we've set up a starting number to square and a maximum number to square. Then we have this min number, which is the counter, and we've got the number squared. So let's see what that looks like. So while num is less than or equal to max number, we're going to output the number, and then we're going to increment the counter. We're going to also square the counter's number. So here we are squaring the counter's number. And so with that, we can see 1, the square is 1, and 2 is 4, and 3 is 9, and so forth and so on. And it's going to keep doing that all the way up until the number is equal to this max number. As long as it's less than or equal to this max number, it's going to keep going. So up to this point, we've been doing the while loop. Now we're going to do and look at the do while loop. It's similar to the while loop, except this is known as a post-test loop. So it's going to execute the loop first and then do the expression. The nice thing about the do while loop is you can always guarantee the first time it's going to do the loop code, and then it's going to validate the expression. So no matter what, the loop code will always get done at least once. The general format is you have the word do out here, your statement or statements. And again, if you wanted to do statements, like this is saying, you would have your curly bracket with that, and then you'd have your while expression. Note that a semicolon is required after this expression. By the way, this is one of the ones that will get you. You're going to miss it, and your code's not going to compile, and you're going to want to rip your hair out by the time you figure out that you literally were missing just a semicolon. It's just a simple mistake. Everyone makes it, and it will be the bane of your existence at least once or twice in your life. This is the logic of the do while, and the important piece here is to understand the statements will always get ran that first time no matter what, because then the expression is looked at and we figure out if we should repeat those instructions. An example of a do while loop. So we've got int x equals 1. We're going to do, and that means we're going to drop into that code. We're going to see out the x and in line, and then we're going to say while x is less than 0. Now, you're saying, well, okay, but x is already 1. So this already doesn't compute. This is, or doesn't already turn into true. That's going to be false at the very beginning. Yes, but we're going to first get that first C out because this is a post of the loop. And so it's going to always do this one time and then execute the expression. It's known as a post-test loop. Here is an example of a do-while loop. Again, go ahead and type that into your online compiler. Play with it a little bit. See how you can manipulate the while statements. And one of the nice things typically with a do statement, and this is not always the case, but with do statements, we often find you don't have to prime the loop because it's always going to do that contents of the loop one time. So you can go ahead and always expect that since it's going to go ahead and run one time, you can do everything in that loop without priming first. Where the while loop, oftentimes you have to prime. Not always, but again, that's a common rule. While loops often need to be primed, the do loops do not. Some loop notes, especially on the do while. Loop always executes at least once. The execution continues as long as that expression is true and stops repetition when the expression becomes false. Just like with the while loop, but now again, it's happening at the end of the execution of the loop rather than the beginning of the execution loop. Useful in menu-driven programs to bring user back to the menu to make another choice. If you were to do a menu-driven program with a while loop, you would have to first prime the loop. You would have to ask the user, you'd have to output the code, like here's your menu, and then ask for the input, and then dive into the while loop saying, do this loop based on whatever the user just picked. And so that's why you would have to prime first and then jump into the while loop. With the do, you don't have to prime it first. You would literally say do, you put the output in there, ask for the input, because it's always going to run that first time. The for loop. All right, now we're getting to some more fun stuff. The for loop is useful for counter-controlled loops. So the general format is we're going to have, and now this gets a little bit more tricky, so understand that the for loop has got three pieces to it. You first have your initialization, then you have the test, and then you have the update. What's nice about the for loop is you can start out by saying, okay, my variable is going to equal 0. Here's the test. So we're going to say, is our variable greater than or equal to 5? And then the update is going to be our variable, oftentimes the plus plus. So initialization, test, and then update. And then our statements. Again, you can also have the block like so. No semicolon after the update expression or the parenthesis. So there is none of that. Here's the mechanics. First, it's going to perform that initialization. That's where we're going to set up our variable. Then it will evaluate the test expression. If it's true, it's going to execute all the statements. If false, it's going to immediately terminate the loop and not go into the statements. And then it's going to execute the update. Then reevaluate the test expression. So one thing to understand is, and this is a little maybe confusing, is the reevaluate the test expression happens after the statement is done, right? So if the test is true, we already know we're going to go into those statements. The update's going to occur, and that reevaluation will happen the next time around on the test. So we're not going to test, update, and then test again immediately. That's not how this works. We're going to test, we're going to do the statements, we're going to test, we're going to update our variable, but we're going to run the statements, and then when we're done, we're going to retest again. So here is a great example. This is our initialization. We've got the count equals 1, and then we're going to do our test, which is test is less than or equal to 5, which is true. So we're going to go ahead and we know we're going to do this C out. But as we are preparing to do that C out, we're going to go ahead and increment count. Now we're going to do the C out. Now we're going to come back up here. We're going to test. And now count is 2. So that's still true. Then we're going to increment again and then do the C out. And we're going to keep doing that until we hit, in this case, 5. This is exactly what I just talked about, where we're doing the initialization, the testing, execute the body, and then we're performing the update expression and then going back to step 2. And then let's make a flowchart of it too as well. Assigning the account to 1. We're going to evaluate. We're going to do the C out statement. We're going to increment, and then we're going to reevaluate. Here is a nice little example of what we did before, but using a for loop. So I'll let you take a look at that and understand it, play with it in your online C++ compiler. And then a close look at lines 15 through 16 in program 5.9. One thing is, remember, we're in this. We know that this is a constant because it's all capital letters. So we're taking that minimum number and we're assigning it. But once that happens in this for loop, it's never going to do this again, only that first time. So it's not like it's going to assign the minimum number to number every single time it hits the for loop. First time, step 1, and then never again. The test, the execute the test expression, it's going to compare the number against the max number, and then that step 4, we're always going to increment by 1. Here's a flowchart of what we just talked about. When to use the for loop. In any situation that clearly requires, it's usually an initialization, a false condition to stop the loop, and an update to occur at the end of each iteration. A good example is usually when you want to do a loop for a certain number of times. Oftentimes, we note that might be going into the code. It might be a variable, but it's always going to be clearly a certain number of times that we want to do the loop. The for loop is a pretest, so that means that upon the first encountering of the for, we are going to test the expression, which means if it the first time fails, then we will never run the code within our for loop. So it is possible to have a for loop that never actually runs. You can have multiple statements in the initialization expression. Separate the statements with a comma. And here you can see that. You can also have multiple statements in the test expression. Separate the statements. And actually, that's funny. Is this is a mistype on this because this is the update expression. So you can have multiple statements in the update expression here, as you can see, because the test expression, by the way, is this. So we're not even talking about the test expression. This is the update expression. And so you can update multiple variables within one test expression. Assuming one one update expression. And you can also omit several of the expressions. You do not need to have an initialization. You may do your initialization somewhere else. Maybe it's already done for you. Maybe it comes from the data. Who knows? But you don't have to actually do the initialization step. And this is just showing you that in the initialization step, you can go ahead and declare the variable type 2. So before, up here, where we were doing this line of int and then filling it in. We can do all of that right in that initialization step. So here we've got the int num all done in one nifty little place. All right, so that is that for this video. The next video, we're going to start at 5.7, keeping a running total. We'll see you then.